Good morning, everybody. This is Gareth Dryden from Open Reality. Thank you for giving up your time this morning to spend half an hour with myself and my colleague from Tintri, Arash Ghazanfari. We are going to be presenting on VMware storage from Tintri this morning. The agenda is, first of all, I'd like to say a very short introduction into Open Reality, and then I shall be passing on to Arash, who's going to be covering everything that you would ever want to know about the Tintri storage platform. Open Reality are a reseller of IT services, products and services, and managed services. We're in our 17th year and we've specialised in application performance. We've built our business and our reputation on our ability to translate the operational needs of our customers into IT solutions that guarantee the fast and effective delivery of applications to happy, efficient users. Last year, we were replacing the storage in our Bright Cloud Managed Services division, and after reviewing many vendors, we ended up selecting Tintri. And everybody was so impressed with the difference it made to our infrastructure as a service business, we decided to add it to our product portfolio so that all of our on-premise customers running virtualized environments could benefit as massively as we have. We supply to a big, broad range of different types of customers, including service providers, system integrators, engineering companies, across all different sectors, the managed services of the public sector, private sector, with very strong associations in housing associations and in healthcare. But I don't want to take up too much time talking about ourselves. I would like at this point to hand over to Arash, who's going to talk to you all about Tintri storage and how it can help improve the performance of your applications of both today and tomorrow.
Thank you, Gareth, and thank you everyone for your time this morning. So the theme of modern technology vendors is to help IT to transition from traditional infrastructures that are hardware-oriented, siloed, and manually driven to more fluid, software-defined architectures of the future, which are basically designed to be automated and are governed by analytics and are governed by repeatable processes. The idea is to make the complexities of infrastructure effectively disappear so that IT can focus on delivering value-adding services to the application layer. And Tintri is trying to approach this problem from a storage perspective. Our founder, Kieran Harty, went to the Bay Area in California in the 90s, and he was Stanford educated. He was then hired by Diane Green, founder of VMware, to run the engineering team at VMware, and he did so successfully for 7 years. And around the time that EMC, the storage company, acquired VMware, Kieran very quickly realized that what VMware is trying to do in the x86 compute layer from a virtualization perspective is inherently incompatible with traditional storage architectures. Because traditional storage architectures are effectively built for physical environments. When an application is sitting on a physical container, it's very easy to create storage resources for that application that are optimized for the performance requirements of that application. But when you virtualize, you create a layer of change friendliness at the compute layer. So storage administrators who are forced to work with those same traditional storage architectures are basically provisioning storage based on capacity requirements, which is the worst thing that you can do, or at best they provision storage which is optimized for a aggregate load, which leads to the current normal, which is the idea of feeding and watering and micromanaging your storage resources, which is something that is generally accepted in our industry. But Tintri is trying to create a new normal where Kieran basically created an architecture that is from the ground up aware of the virtual machines, and it's underpinned by an analytics engine and an intelligent file system that can self-optimize and respond gracefully to a fluidity that you see in the compute layer without any human intervention. Some of the architectural properties of Tintri I'm going to mention now, the first one being visibility. The idea is that you are managing your storage from a VM-centric perspective, from a virtual machine and application-centric perspective. So At a virtual machine level, we give you that end-to-end visibility along the entire data path so that you can very quickly build an understanding of where the bottlenecks might be within your infrastructure. And at a grand scale, we can give you opportunities to apply application-centric policies to up to 160,000 virtual machines from a single pane of glass, which would reduce your operational burden as you scale. The second property of Tintri's architecture is around how we handle performance and how we handle contention. So with Tintri, we move away from the notion of a LUN or a volume, which is effectively a contention domain due to its first-in, first-out architecture. And each virtual machine in a Tintri appliance will get its own dynamic dedicated I/O lane. And that I/O lane is dynamic in nature, not just from a bandwidth perspective, but also from an I/O characteristic point of view. So a workload that might be a write-intensive workload, such as a database doing a full write ingest, will get a write-optimized I/O lane, and that same workload could be switched to some kind of business analytics or data mining type activity, and that would need to be a read-intensive I/O lane, and the analytics engine is constantly monitoring the normal state of operation of VMs and responding to that change accordingly. And because we can, we have that visibility, we can rapidly right-size what each virtual machine needs so that we optimize the performance real estate and the use of the performance resources that are available at the storage layer. The third property is scale. So as Tintri customers, you'll have the opportunity to scale from multiple terabytes to multiple petabytes without increasing your operational burden and without really adding any more resources to your operations team, which is why service providers are probably, I would say, the fastest growing sector in Tintri's business, because as you scale, you need to be able to control your costs, and service providers, through the use of Tintri technology, can reduce their cost per application and cost per virtual machine significantly with Tintri. If you have a multi-hypervisor strategy in your organization, you can absolutely mix different virtual machines from different hypervisors on the same platform, but more importantly, you get the opportunity to mix infrastructure-grade workloads with end-user compute-grade workloads, I/O-intensive workloads with latency-sensitive applications, all on the same platform without increasing the complexity and without creating silos of storage resource. And that is the power of Tintri's analytics in full action. A good example would be one of our larger customers. This is Autodesk, the company behind AutoCAD software. They have a software as a service offering, and as part of that service, which is a cloud service, they need to create 50,000 new virtual machines every month across 8 data centers, over 75 Tintri appliances with an addressable storage of 2.6 petabytes. And today, all of that change and transition is costing them only 4 man-hours per week, and that's largely thanks to Tintri's programmable and automatable and VM-centric, virtual machine-centric architecture. Another example is a recent customer, Green Cloud. This is a service provider in the States, and upon adopting Tintri storage technology, they have now managed to increase their business size 20-fold without adding a single individual to their existing operations team. And they're very grateful for that because they can now offer differentiated services and they can also control their costs as they grow. A little bit on the Tintri product portfolio. So we basically sell hardware appliances, but the value is in the software that comes with those appliances. And I'd like to take a closer look at the portfolio, if I may. So a little bit on the product lineup. We understand that the flash storage market is changing. Larger and less expensive solid-state drives are now becoming available, and so Tintri is increasing the range of its all-flash appliances. But the hybrid appliance is continuing to satisfy 95% of the use cases that we come across. And what I would like you to pay attention to is the level of density that you can achieve with these appliances. Because regardless of which flavor you go for, small, medium, or large, the hybrid appliance is only 4 rack units in size, and the all-flash appliance is only 2 rack units in size. And imagine fitting, 2,500 virtual machines in a 2U unit, that is a significant level of density and a significant level of efficiency that you can only get from a VM-aware storage that is underpinned by intelligent VM-centric analytics. Our architecture is a flash-first architecture. So in the case of our all-flash T5000 series appliance, all reads and all writes are serviced by the flash tier. In the case of the hybrid appliance, all writes are committed to flash, and 99% of all reads come from flash as well. And for those 1 or 2% of read I/O that we might miss, they will be delivered from a wide pool of mechanical drives, so the performance impact is actually nominal. And this is why the hybrid platform continues to satisfy a large number of use cases. But for Tintri, the conversation isn't really about mechanical drive versus solid-state drive. It's about analytics delivering the right level of performance where and when it's required in the context of virtual machines and the applications that are sitting on those virtual machines. Briefly going over the software features, if I may. From a replication perspective, we believe that replicating LUNs and volumes is wasteful because you end up potentially replicating workloads that don't need to be replicated. With Tintri, we give you the opportunity to be selective about what virtual machines you're replicating and what policies and characteristics around disaster recovery and business continuity should be applied to those virtual machines. And because we are aware of compression and deduplication at a global level, we can significantly reduce the WAN footprint and significantly reduce the connectivity costs associated with disaster recovery and business continuity. For secure environments, we give you the opportunity to encrypt your data at rest, and because we are using self-encrypting drives, the impact on performance and capacity is zero. And it's a simple case of activating a license, and you gain the opportunity to have the flexibility to replicate between encrypted to non-encrypted appliances. So the last sort of native software capability is SyncVM. So SyncVM, without it, you absolutely can create space-efficient snaps and clones of your virtual machines. But with SyncVM, you get an additional layer of automation and orchestration to satisfy a number of use cases. The first use case would be the ability to move a virtual machine back in time to perhaps examine its guest OS state, perhaps examine for, look for any sort of corruption issues, or maybe test and development. And you can then bring that same virtual machine back to the present moment without losing its data and losing its identity. The second use case would be to mount a space-efficient snap of a specific virtual disk of a VM, and you can map that snap back onto the virtual machine itself and do single file level recovery to, for example, recover a lost file that was accidentally deleted, or recover a database from application level corruption. This by no means is a backup replacement tool. This is just another tool that you can have in your arsenal to have a more flexible approach to handling some of the use cases that I just described. And the last use case, which is gaining momentum in test and development environments and also application delivery type lines of businesses, is the ability to selectively refresh data disks in child VMs from a data disk coming from a master VM. The example for this would be, for example, a production-grade database that is copies of which are being made available to test and dev, quality assurance, and financial modeling guys. And at some point, the data that these work groups would be working with would deviate from the latest version of the master database. And with SyncVM, within literally seconds or minutes, you can refresh the content of the database or the data sets that various work groups are working with without affecting their operating systems and without affecting their specific applications. And this is an excellent use case. Because we're using space-efficient technology, we can significantly decrease the storage overhead associated with such activities. We have Tintri Global Center. As I mentioned earlier, you can manage up to 160,000 virtual machines from a single pane of glass and apply application-centric policies to those virtual machines. And you can continue to enjoy the RESTful API framework of Tintri, to enjoy the automation and programmability capabilities of Tintri. But we are also adding advanced capabilities. For example, you can now have a federated pool of storage resource that can self-optimize. And the idea is that we can have a scale-out approach that is federated, and that federated architectural approach gives you the flexibility to independently scale compute and storage resources, which is really in line with the grain of virtualization. The whole point of virtualization is that you can intelligently scale different resource disciplines independently of each other. And with Tintri's approach, you get the opportunity to balance capacity and performance and basically accommodate existing systems as well as future systems and protect your investment in Tintri. And as you scale, continue to have that zero-touch approach to micromanaging storage, because the storage resources can intelligently, through a policy-driven approach, self-optimize according to the needs of your application environment. And as you scale, you will continue to maintain that per VM granular visibility, as well as having the ability to influence the performance of your applications by creating policies that allow you to create differentiated services towards your business and your end users. Now, we have integration with other hypervisors as well, like Hyper-V and OpenStack. But I use VMware as an example here. We give you the opportunity to have a vCenter plugin and initiate Tintri actions directly from within vCenter. And again, it's free of charge. And there is another management pack available for VMware's vRealize Operations Manager tool to expose Tintri level intelligence to Operations Manager level. Again, that is available to you free of charge. And because of our programmable interface, we can integrate with vRealize Orchestrator or vRealize Automation or any other automation and orchestration tool that can talk to a RESTful API interface, such as, for example, the likes of ServiceNow and so on. A few use cases, if I may, and then we can jump onto the demo. The first one being around VDI. And in our travels, and also based on independent studies that have been done in the industry, the most complex area in VDI happens to be storage, for the reasons that we described earlier. That incompatibility with traditional storage and fluidity that you get with compute level, and the fluidity and the unpredictability that you get from an end user perspective, leads to poor end user experience or significant costs associated with storage to over-provision resources to effectively stop bottlenecks happening within a VDI environment. With Tintri, every time we get involved, we eliminate storage problems associated with VDI. And these are just a handful of referenceable use cases where Tintri has been successful in doing so. And we are getting involved with very large VDI projects, 50,000 seat, 80 to 100,000 seat VDI environments running on Tintri. Another use case is private cloud. And we give IT environments the opportunity to behave like service providers towards their business, and we give service providers the opportunity to create differentiated services for their customers. And Bright Cloud is a good example, and they're one of our main service provider partners here in the UK as well. And they're leveraging Tintri technology to control their costs and offer innovative and differentiated services to their customers. The last use case, which is an interesting one, is the US Department of Defense. This is a software development scenario where they managed to reduce the time to deploy of their test and dev environment. Every time they had to refresh it, it took them 2 weeks to deploy and 8 hours to prepare. And that timeline has been drastically reduced through the use of Tintri technology. And they were so impressed with what Tintri has achieved in this space that, being the type of organization they are, it's amazing that they are a public referenceable account for us. Over to you, Gareth.
Okay, thanks very much for that, Arash. Well, As a call to action, we hope you've enjoyed all of this. We would obviously very much like to come and meet you guys and talk with you about your individual requirements. But we're running a separate promotion on our website called Time is Money, where there's an assessment tool that you can download. It's a free tool. It's called RB Tools. And if you run that tool, what we hope you'd be able to see is, and send a report back to us, is that we'll be able to give you a personalised report showing you exactly how much time and money and how that you can save deploying Tintri over conventional storage, and how much less you have to over provision your storage requirements. But you know, we'll send out a follow-up following on from this meeting to everyone, and get in touch and see if you want to take up our offer on that. In the meantime, if anybody's got any questions, that would be a really good time to ask. And if you've got a few minutes, Arash will be able to do a very short demo. Arash.
I absolutely, and I wonder if we need to unmute the attendees. Could someone do that, please? So whilst you're being unmuted, I'm going to show you a quick demo, if I may. And again, I thank you for your continued attention and patience. So these are some systems that are currently in Mountain View, California, a mixture of hybrid and all-flash arrays that I've logged onto. Not much is brilliant. So not much is going on at the moment, but I just wanted to show you the interface. The interface is fairly simple and consistent across the range, with the exception that with the hybrid platform you get this flash hit ratio construct, which obviously you will not get with the all-flash array. I'll stick with the hybrid platform, if I may. At the top, this is the main screen, and you know, you can see an application-centric view of the world. So from an application owner's point of view, they're concerned with how much data they're pushing down the pipe and what is the level of response time that they're getting from the storage resource.
What I'm also doing this is we're going to have to build new academy servers fairly soon.
Okay, and so across the array, we can actually get that visibility very, very quickly. If I just quickly click on the IOPS figure of this particular array, we can see the real-time characteristics of the I/O profile. We can see that the I/O profile at the moment is really intensive, and we can also go back in time and see, for example, what was responsible for this particular peak at this specific point in time. And we can very quickly establish that that specific virtual machine was responsible for 37% of the overall performance footprint of the array. And we get a sense of the workload skew at that specific point in time. So if there are any anomalies or abnormal behavior, historical abnormal behavior, we can absolutely find out. And from a predictive perspective, we also get a sense of the trends that are currently happening in the environment. So we can see which virtual machines are trending from a performance and from a capacity point of view. So if, for example, a specific virtual machine increases performance footprint all of a sudden by 60 to 100 or 120%, we can probably guess that something, some anomalous behavior is going on, and we can examine it more closely. And I think this is quite interesting, where you get a sense of the performance reserves as well as capacity reserves. So from a capacity perspective, we can show you live data. We can show you the amount of VMware hypervisor snapshots, for example, or the amount of Tintri snapshots, and we can also give you the visibility over the, we can give you visibility over the space efficiencies that you can currently achieve based on the data set that you're throwing at the array. And additionally, we give you visibility of the amount of data that is traversing across the link from a protection point of view. Now, if I hover over this particular box here, you see two figures. One is the figure in blue, which is the storage component of the latency, and the other one is the end-to-end component of the latency from the array perspective. And we can give you the same level of visibility on a per VM basis. So if I could bring the virtual machines up and sort per latency, we can very quickly build an understanding of what virtual machine is suffering from high levels of latency. And because the latency bar is color-coded, I can see that the majority of this one is green. We are obviously doing some unnatural things to the specific VM in the lab to simulate host-level latency. And because we get visibility of not just the traditional storage metrics, but also we gain visibility of host-related metrics as well, and network-related metrics too. If a host CPU is highly utilized, that is a sure sign of an overpopulated host, or if a VM is doing excessive swapping, that might be an indication of the virtual machine not having enough memory resources, or there might be something wrong with the application behavior, which you can which you can focus on rather than just blindly adding more spindles to your storage in a bid to resolve the performance problems. So it really minimizes, and I would say to a certain extent eliminates that finger pointing exercise and allows you to understand the issues very, very quickly. Now let's say you want to find a particularly noisy virtual machine. So in this case, I have sorted based on IOPS, and I'm going to double-click on that specific VM to see the specific virtual machine's behavior. Again, fairly read-intensive I/O workload for this specific VM. And perhaps this VM is generating too much workload, and I don't want it to potentially impact my production environment. So I can go ahead and, first of all, activate the quality of service view. The quality of service view enables me to see the normalized I/O profile for this VM as well, because IOPS on their own are meaningless. With Tintri, every I/O gets normalized around 8K blocks, so that when you go ahead and right-click on the VM and configure the manual quality of service on the specific VM and start setting some boundaries around it, when you say, for example, put 4,000 IOPS, because it's normalized IOPS, you get to see the effective bandwidth as a result of that policy being applied to that VM. So if I hit configure, I have very quickly now established an outer limit for the performance footprint of that specific virtual machine. And not only I can see the impact of what I have done in real time on IOPS, but I can also see the impact of what we've done on latency. So you can see that latency is now starting to climb, and a significant portion of that latency is going to be due to the manual throttling that I've just applied to that specific VM. Everything is happening in real time. This is actionable, intelligent analytics being applied on a per VM basis. And of course, you can apply this more intelligently at Tintri Global Center level on a per application basis, because an application could be serviced by a number of virtual machines. And you can absolutely have an application-centric policy rather than having to micromanage storage resources. Now, let's say I feel a little bit more generous and I want to perhaps control what I've done graphically. I can do that by simply elevating that line slightly higher, and equally I could have a reservation policy as well to control the I/O profile of a particularly noisy workload or a mission-critical workload. Both of them are obviously possible. Now, very easily, I can just right-click on a VM and look at its protection policies, and I can apply appliance-wide or individual VM protection policies, and I can say, well, I want, for example, some of them to be crash consistent and others to be virtual machine consistent, and I can apply different retention policies for local and remote replication instances. And I can very quickly select which target system I want this particular VM to replicate to. Again, all of this is very easy to do. And everything that I am showing you today, including the changing of the QoS policies that I'm doing graphically, is generating a RESTful API command in the background. And so you can automate all of this using various automation and orchestration tools. And with that, I'd like to thank you for your time, and that concludes my demo. Gareth?
Arash, thank you very much. Thanks everybody for attending. We will be putting a recording of the webinar up on our website, and we'll be getting in touch with everybody with a follow-up to invite. But again, thank you very much for Arash for your great presentation and demonstration, and we look forward to speaking with you all again soon.
Thank you very much.
Thank you.